Hello, ladies and gentlemen. How are we doing today? Oh, let me keep this out. That. Holy cow. All right. So, all right. So we're going to take a look at questions, the worksheet questions from uh, module um, module 3. We're going to take a look at questions module 3. And if we take a look at the uh, first set of questions, you're supposed to watch the Jason Welker's video on scarcity, opportunity cost, and production possibility curve video found at that username or that video right there. So it says, as students watch the tutorial, have them write down on how the PPC module demonstrates scarcity and those things. So um, it goes through and says, what is scarcity? And we know that it's scarcity is the fundamental economic problem with unlimited wants. We have unlimited, wants. Um, we have unlimited wants, but to compete with limited resources. So we have unlimited wants, but we have limited resources. So unlimited wants with limited resources. So that makes everything scarce. Then it says, what is opportunity cost? Opportunities cost is what you have to give up uh, or what you lost when you make choices. So it's the next best alternative or what you gave up, right? What you gave up on that. Okay, that would be what opportunity cost. Then it says, what is the production possibility curve? The production possibility curve shows us the trade-offs between two goods, right? Two things. Okay. When everything is scarce, remember we said with the production possibility curve, there are two items. Um, certain assumptions we know that are fixed. We know that technology and resources and things like that are fixed, and that we have the trade-off between one thing or another. And when we have numbers, we can calculate the opportunity cost. Okay. The next part says then use a chart to create a production possibility curve showing the time you can spend either working or playing. The other 12 hours of the day are committed to sleep and family time. You cannot make choices. You cannot make choices to use them in your day. All right, place play on the vertical axis and work on the horizontal axis. So that's what I did. Play on the vertical, and so I have the time frame here. So let's choose a different color. We'll go with red. So we have given that number. If we're at point A, that would be 0 work, 12 hours of play. So that would be A. Then it says 3 and 9. So that would be like right here. This would be B. And then 6 and 6 would be like right here. And then 9 and 3 would be right here. And then so this would be C, D, and E. And then we'd have oops, sorry, that's not very good. It's supposed to be a straight line, but I'm drawing on the computer. I apologize. So that's the kind of curve that I got for that. So it's a straight line. We could tell by looking at this data that this is a constant opportunity cost, So if we take a look at the questions here, it says here, assume you decide to spend all of your time playing. What is your opportunity cost for this decision? Well, your opportunity cost to spend all your time playing, you're giving up 12 hours of work, right? Um, because I can't work for those 12 hours if I'm playing for 12 hours. So, oops, this was two. I gave up 12 hours of work to play 12 hours of play. Um, Number 6 says the next day you decide to only spend 6 hours play. What is your opportunity cost for this decision? Well, once again, you gave up 6 hours of work that you could have done, right? Because you can't work 6 hours because you're playing for 6 hours. Number 7 says now you decide you want to work 8 hours and play 8 hours plot that point on your graph and label that F. So 8 hours and 8 hours. So if we go back to our graph, 8 hours would be here, and 8 hours would be here. So that would be right there. And they said plot that F, right? Right there will be F. That's outside of our curve. So what do we know is happening? Okay. You can't, if you do 8 hours of work, 8 hours of play, that's 16 hours, but you only have 12 hours. So if you do eight, oh, of course, my pen doesn't work now. Um, if you do 8 hours of play and 8 hours of work, that's 16 hours, but you're only allowed 12 hours. So technically, it's unattainable. You can't do that, right? Because you have other commitments for 12 hours, so it's not possible. You can't be there. It's unattainable, right? Then it says number 8 here, it says, what if you decide to spend 6 hours of playing and 4 hours of work? Plot that point and name that G. So 6 hours of play, 4 hours of work. So we go back up here, 6 hours of play and 4 hours of work. So that puts you here, and I said label that G, right? So there you're inside. So now that's inefficient, isn't it? All right. So how would that impact your life? Number 8, it says, um, I now have extra hours that are unused, right? This is not efficient, right? As I could do more of one of the activity. I could do more. I mean, because 6 plus the 4 is 10. I said I had 12 hours. So I have 2 more hours that I could either 2 hours of play, 2 hours of work, 1 hour of play, 1 hour of work. Like I could divide that up. Okay. So I can make that choice, but I'm not efficient. So number 9 then says, if we go through, it's asking you, how does the production possibility curve demonstrate the following concepts? So scarcity, it shows the max combo of what you could produce, right? We cannot produce more than our resources allow. So when we think of the production possibility curve, this, we can't be out here, it's on a table, and inside here is inefficient, right? So then it says, what is opportunity cost? Well, once again, opportunity cost is what we're giving up. So it's essentially the cost of our trade-off, right? Our trade-off, right? It's the next best alternative, right? And that's our trade-off, right? It shows the combination of what I have to give up, right? That's what a trade-off is, right? It's giving up, right? What you have to give up. Efficiency. What does this graph show us about efficiency? That at any point on the line, we're being the most efficient. We are maximizing our resources and our technology. Okay, it's showing us that where we're maximizing all of our resources, all of our inputs, right? And then the next one, E says, what about inefficiency? Well, if we're inside that graph, once again, so if we're inside, let's try a different color here. So if we're inside here, inside that means we're inefficient, right? At any point inside the curve is inefficiency because we can actually produce more of either one of them. We can produce more of either one of them, and we're just not at that point. Okay, so that's inefficient. So then that leads us to 3.3. Okay, and once again, you're watching a Jacob Clifford video, which I have on there, and it says, what are the factors of production? We have land, labor, capital, and entrepreneurship. Land, labor, capital, and entrepreneurship. Those are our factors of production, right? You need all of those to produce anything. Next, it has a chart here. It says use a chart to create a production possibility curve. Use bubblegum on the vertical and barrels on the horizontal. So I went ahead and I already started these. So this is point A, B, C, D, and E. And I will do my darndest on this bad boy here to try to make the lines connect. Okay, not too bad. That wasn't too bad. Okay. So that's kind of what you should have, right? And then it asks you a bunch of questions down here. It says, for number 3, label the following: uh, inefficient or unemployment, label M. So that could be anywhere. So let's just put right here M, because that's pretty much anywhere. It says just inefficient or unemployment. That's M right there. Boom, done. Right. Then it says label something efficient, N. Well, I'm going to put right here, N. That's on the line. Anywhere you could have put that. I could have put N. I could have put N here. I could put N here. Oh, of course, the pen now doesn't work. Oh, pen, come on, pen. All right. I could have put N here, here, anywhere on that line would be efficient. Then when it says, then for C, it says unattainable, 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 and label that P. So I'm going to put way over here, P. But P could have been here, P could have been here, just pretty much anywhere you want. Now it says to calculate. Now it says to calculate going from point A to B, what's your opportunity cost? So from going from A to B, so I'm going to slide up a little bit so we can look at the numbers too. So going from A to B. So going from A to B, to make one barrel, I had to give up 2 bubble gums. So from A to B, my opportunity cost to produce 1 barrel was 2 bubble gums. To go from B to C, B to C, once again, I'm making 1 here. So what did I have to do? I had to give up 4 bubble gums. 4 bubble gums. Then it says E to D, E to D, E to D. So to go from E to D, I went from 0 bubblegums to 16 bubblegums. So what is my opportunity cost to go from E to D? Well, that's 1 barrel. That's 1 barrel. Then it goes from C all the way to A. So let's think from C to A. So I'm going from 24 bubblegums to 30 bubblegums. How much barrels did I have to give up? I had to give up 2 barrels. So your answers for A here should have been 2 bubble gums. I'm going to just put 2 bubble gums. For B to C, once again, was 4 bubble gums. Then from E to D was 1 barrel. And from C to A was 2 barrels. Okay? All right. Next, it says draw a graph that shows constant costs. So we could calculate, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say this is 10. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Constant would be essentially, no, that's not very good. Essentially a straight line. A constant opportunity cost, that's a straight line, right? A constant because resources are easily adaptable from one product to another. So when we actually explain, constant opportunity cost occurs because you have easy to move from whatever this product is. Let's say this is apples and oranges. We go from one to the other. Okay. The next one asks you to draw um, to draw an increase in opportunity cost. So that's going to be more like this: increase in opportunity cost. This occurs because it's not easy to go from whatever this product is. We'll call this X and Y, right? Or actually, oops, if we do, this is the X coordinates, this is the Y. Going from Y to X is not easy. So you get this roundedness and this steeperness, right? Because it's not easy to go from one to the other. Okay. So that is exercise or page 3.3. So let's take a look at now 3.4. I don't know why that's up there, but 3.4 says using a given production possibility curve as a starting point, correctly label and graph the results. Label and graph the results for that. So let's take a look here. Right, 3.4, right? That's what we're doing, 3.4. All right, so 3.4 says here, this first one says there's an increase in unemployment, right? Um, increase in unemployment in a nation using all of its resources and producing 20 boats on the horizontal. So 20 here, and we'll put this as boats, and the 60 cheese balls. So I'm just going to put, but you always have to label things, right? Um, and it says an increased unemployment. So an increased unemployment would put us, you'd put like a little dot right there. That's what would happen with increased unemployment. So I labeled it. Okay. The next one says um, there's a decrease in technology in the nation using all of its resources. So it has 100 kites on the vertical. So we'll put 100 here, kites, and then 25 bales of hay or 25 bales of hay. And it says that there's a decreasing technology in all. So that would be this, right? A shift inward. Okay. The next one says, suppose the nation is using all the resources it can produce 20 computers on the horizontal. So we'll put 20 computers here and 80 bottles of salad dressing. 80 bottles of salad dressing. Okay. And it says that and zero. All right. So it's at 80 bottles. So it says if it's at, hold on, 20 bottles. The nation currently producing 10 computers. So 2, 4, 6, 8, 10. Just wait. And 40. So we're like right in the middle. So I don't know. We'll just say right here. Okay. And label that point at point A. All right. So that's point A. And it says the residents express a desire for more computers. So more computers would make us slide down this to here to B. Okay. So that would be what that graph looks like. The next one says that a blight destroys 80% of the potato crops in the nation using all of its resources and producing 400 bolts on the horizontal. So 400, wait, yeah, 400 bolts, 400 on the horizontal, and 600 chips on the vertical. So it says that there's a blight destroying 80% of the potato chip thing, but it doesn't affect the bolts. So what would happen? You would get this, like this, and you get that shift inward. You'd still start right here at the same spot, but you would see the uh, because there's a blight in the potato crop, and potatoes are used for chips. So therefore, the price of potatoes are going to go up. So therefore, that's an input, a resource, an input. So the cost is going to go up. So they have to buy less potatoes, and that's going to cause the production to shift inward. The next one says there's an increase in the population using all its resources. So you have 100 T-shirts on the vertical. So we have 100 T-shirts, tees, and then 100 baseballs. Oh wait, I'm sorry. Baseballs. What did it say? Oh, T-shirts are on the vertical. So 100 T-shirts here, and it says baseballs on the horizontal. So here's baseballs. My bad. And it says there's an increase in the population. Increase in the population. That would be this. Well, that's not very accurate, but let's see if I can go back. Oh no, shoot! It took us all the way back. That's not what we wanted. Yeah, I didn't do a very good job there. Right here. So that would just take us a shift. Oh gosh, that would take us to there. Shift outward. Maybe I should use a different color. Oops, that's wide. All right. The next one. The next one says there's an. Um, so this one says that there's what is there? 500 candy bars on the vertical. So here's 500 candy bars. And then 30 trucks. There's 30 trucks on the horizontal. And it says there's an increase in capital investment in our nation using all its resources and producing. So capital investment means that we're able to produce more capital goods, but yet by producing more capital goods, we're also going to be able to produce more consumer goods because there's more capital goods to produce consumer goods. So this is what it'll be shifting outward. The whole curve will be shifting outward. Okay. So that. And then let's see. So now it says you have two nations, nation A, nation B, nation A, nation B, and it asks you between earphones and lollipops. So it's going to ask you to calculate opportunity costs. So let's take a look here. So the first one says, so it says here, nation A and B are each producing lollipops and earphones. Assume each nation is producing 12 earphones and 0 lollipops. So if they're all both producing right here, boom and boom, okay? Then it says, what is the opportunity cost for each nation to increase production from 0 to 1? 0 to 1. So we're talking up 1 to right here and up 1 to right here. So what would be the opportunity cost for nation A? That would be nation A to produce 1 lollipop, they'd have to give up 2 earbuds. And for nation B, they are giving up 4 earbuds. All right. Then it asks for what is the opportunity cost going from 1 to 2. So now 2 would be here, 2 would be here. So we could see it's going, so now I'm not going to scroll down, but for number two, they, nation A would be giving up what is that? 4 earbuds, and nation B would be giving up 4 earbuds, right? 4 earbuds. Then question 3 says going from 2 to 3. So we're here and we're here. So now for question 3, so this was question 2. So now question 3 says, what's that? So for nation A, that would be 6 earbuds, and they would be, for this nation B, would be 4 earbuds. Okay, so that would have been the answers for down here. So let's just put, it was 4 earbuds here. It would be 4 earbuds here. You always want to label what they are. 6 earbuds here and 4 earbuds here. We know nation A has an increasing opportunity cost. Nation B, it's a constant, right? So nation A has an increasing, so it says, what can we deduct from here? Nation A has an increasing opportunity cost. Nation B has a constant, opportunity cost. All right. And then the last one, there are 3 multiple choice questions. So the first one says here, technological improvements will, and if you take a look, your answer should have been C, shift the production possibility curve outward. Number 2 says efficient production exists when the economy is, and the answer would be B, operating on its production possibility curve. And number 3 says the process through which an economy's production possibility curve shifts outward is I don't know why A is jacked up like that, but that would be B, economic growth. We would see economic growth. Okay, so that's the last of the worksheets there. So if there's any questions or anything like that, please reach out to me. But these are the answers to the worksheets that are in the back, and many of these questions are in your booklet also. All right, well, have a great day, and we'll talk to you soon.